So this video is going to be very short, and it's just going to cover basically that in line integrals we've been talking about having curves, and this curve C, and C is generally denoted to represent basically the path that we're going to be doing our integration over. But it's entirely possible to have something that is consisting of multiple pieces, like something like this perhaps, and they will still call this the path C, but it'll consist of like, a first part C1 and a first part C2, and they'll give you an orientation for each one, and they still might ask you to calculate the integral over C of whether it's some scalar function or some vector field. They'll ask you to do the line integral over C. And so the way you tackle this is you simply split this into two line integrals. So you do like C1 plus the line integral over C2, and you just add the total results. Why would you need to do this? Because maybe you're trying to parameterize a straight line, which isn't so bad, but then maybe you're also trying to, this section is described by part of a circle, which is maybe parameterized better with sine and cosine and so on and so forth. So that's like just kind of one little tidbit. The last little tidbit that I wanted to just not forget to say is that if our curve, let's say, consists of multiple pieces, it could actually even just consist of one, but let's say it consists of multiple pieces like so that basically end where it begins. So this is C1 and this next piece here is C2. This line integral, a line integral that goes over C1 to C2, this is what we call a closed path. This is what we call a closed path versus this one here, which is an open path, as is the one to the right. And why do we care about that, right? Why do we care that it ends where it starts? The only thing that we really care about is that when we do a line integral calculation over C, where C is going to represent the totality of this path, you'll see the integrals will have this little loop right here of, again, whether it's a vector field or just a scalar function. And this right here, this little loop simply means that the path is closed. Okay, the path is closed. It starts and ends in the same place. And so this will actually be important next week when we introduce Green's theorem and the fundamental theorem of line integrals, because closed paths in conservative vector fields have the really nice property that the line integral actually ends up being equal to 0. So just a little bit of tidbit to pay attention to. You might see it on your homework. Yeah, but nothing to be afraid of. So hopefully that was helpful, and see you all in the next one.